Hi. In this video I will show you in the terminal how to get in touch with programming in C. I will begin with a traditional first Hello World program, so we have to use an editor in order to type this in. And there I want to show you how to use Vim in a minimal configuration at least, so that you have syntax highlighting, for example. Then I will show you how to translate this source code into an executable using GCC and how to invoke, how to execute this program that you created. Then I also want to show you more options that you can use together with GCC so that you, for example, can give this executable some different name, different from the default a.out, and also some other options that you, of course, can read up with man GCC. But I also want to give you a first introduction to the concept of Unix processes. Basically, you have to think about programs that run on Unix as if they would run inside of a bubble. Maybe you know the movie Matrix, then you know what I'm talking about, except that in this matrix there's only one person, this program that runs, and this program has the illusion that it's the possessor of the complete own computer, that it has its own memory, its own CPU, and that it's also connected with some input-output devices. Input device would be the keyboard, and the output device, the terminal. Think of it like that. And then I also want to show you how every process leaves behind some exit code that we can look up after the program terminated. Okay, so that's it for the overview. Now I will go to the terminal. Now let me first show you how everything works when I'm using my configuration, and then I show you how to get at least some similar minimalistic configuration, for example, of Vim. Now the terminal on the left I will use for creating this file hello.c using Vim. You already got a quick introduction to Vim, so you know I'm currently in the command mode, and now by pressing I switched into insert mode, so I actually can begin with typing. And then you see, first of all, I have syntax highlighting on by default. Then also notice that if I now type in a closed parenthesis, I get a visual feedback that parentheses are matching. Also note after this curly open parenthesis, when I hit the return key, I get automatically this indent, important for a nice coding style. Then let me finish this. Then when I now type in this closed curly parenthesis, I also get this feedback, but I also get this automatic alignment of this matching parenthesis. And these are nice things that they happen automatically because it helps you to have nice code. So now I switch to command mode and just save it. I will show you later how to get this default behavior in case it's different in your editor. Now let's first show you how to translate it into an executable. GCC hello.c like that, and then you have an a.out that you can execute. Okay, now before I show you more options that you can use together with GCC, let's make sure that you have some at least minimalistic nice configuration of Vim, so that you, for example, have syntax highlighting and so on. You have to know that in your home directory there might be some file called .vimrc. If that's the case, this configuration will be used by Vim for setting syntax highlighting and other stuff. Now I will not remove my vimrc, but I will rename it so that I can show you how Vim looks like in some initial state where you don't have all these configurations. And I will open here vimrc in Vim so that I show you how certain effects can be made permanently. Now, because this file is empty and Vim starts reading this empty file, it's reading an empty configuration, so it has a default behavior, which has no syntax highlighting for a C program. Now I can do two things. I can turn on syntax highlighting for one session. That means if I go out of Vim and then back in, it's gone, this configuration. But let me first show you how to do this in a session. I was in command mode, then hit the colon key, and then I type in syntax on, and then I have syntax highlighting. And in order to make that permanent, just to show you, if you go out and back in, it's gone. I go here into this file.vimrc on the right hand side, and I here type in syntax on. Then I can save it, go back to the terminal on the left, quit Vim, go back in, and now I always have syntax highlighting if the file extension is known by Vim. And for .c, that's the case. Now a few other things are gone. For example, if I now go into insert mode after this open parenthesis with lowercase a, hit return, I don't have this indent by default. In order to get that, I can again, I'm in command mode, type in colon and use the command set c indent. Now I'm back in the editor. In command mode, I type in a lowercase a, I hit the return key, and then I get this indent, but not as I wanted. This is now an indent of 8, and I want to have an indent of 4. Now, in order to get this indent behavior that I prefer, I have to do a few more things. Let's make all that permanent. So first of all, let's insert this set indent, C indent into this vimrc. What I also want is I want to set the indent level, the shift width to 4. I also want to use tabs in order to indent by this shift width, but I don't want to change the tab stop itself. What I want is I want the so-called soft tab stop to be the same as my shift width, and I want to have the default size of a tab stop, which is 8. So if you prefer a different level of indent, it's okay. Then you have to change this shift width and this soft tab stop, but please don't change the tab stop. Also, if you already have some vimrc with some nice features, of course you don't have to remove them, but make sure that at least these 5 things are in your vimrc so that you can make good use of Vim. Okay, and now if I go back to this Vim and remove this line, I have now the right behavior when I'm starting it. Okay, now we can go back to GCC and how to use some other options. If I want to call the executable hello instead of a.out, I can use the option dash lowercase o hello, and then the source file is still hello.c, and now it creates this executable hello, which is doing the same as before, of course. Another option I usually always use is the option dash uppercase W all. This will turn on all warnings. So if something is suspicious in my code, GCC will warn me. In this case, that should not be happening. And of course, you also can combine these options. You can say, I want to have all warnings, and I want to have an executable called hello, and I want to compile hello.c. Then you combine it, of course, like that. What you should not do is combine it as follows: dash lowercase o, dash uppercase W all, hello, hello.c. Because you see this tokens dash o and hello belong together. I mean, first you say here the next token specifies the name of the executable, and then the name of the executable should follow and not the option here. So in this case you get an error because after this option you don't have a file name, you have this other option specified. What you also see here, and that's for the Mac users, that if you're working on a Mac like I do, GCC is actually Clang. Apple had this idea to give it a fake name. Clang is just a different C compiler, but there is only one problem for the Mac users. If you want to look up the man page of GCC and you type in man GCC, Apple has not installed any man pages for Clang. So in that case, you have to know that on Mac, if you're using homebrew, GCC is actually, for example, GCC, like in my case, -11. Just type in GCC dash, hit twice the tab key, and then you see what's your current version. So Mac users have to type in man GCC-11 to get the man page of GCC, and they also have to use GCC-11 if you actually want to use GCC for doing things. Okay, looking up the man pages, I already showed you how to do that, and also how to go out of this man pages. What else can we do? I mean, let's go back to this C code. I haven't given you a good explanation about what this C code is actually representing, but let me briefly tell you what we hear is a so-called definition of a function main with a return value int. And the special thing about C is that everything is organized in functions, and this function main will be the first function that gets invoked, called when you run your program. And that means execution starts with this main functions, and it will do all the statements that are defined within this function body. Now this function returns an int, that means it returns an integer value. How can we actually see that? I mean, I don't have here a return statement. The special thing about the main function is that it always returns 0 by default. We don't have some different return value. And how can we actually see how this function returns something? Well, you have to know that every program in Unix is running within a so-called Unix process, something like a bubble. And once this program terminated, this bubble just puffs. But on the shell, I can read the so-called exit code of the last Unix command that was executed from the shell. Let me show you what I mean. Let's compile this. I mean, actually, it didn't really change it. And invoke it. Now the executable is a.out. Then with echo $? I can get the exit code of the last command, which was a.out, which is the program that I have here in C. Now I can change this exit code here, this return value of main, which will be the exit code of my program, to 42, and then run GCC again to create a.out, and then echo $? Gives me this 42. What else can we learn here about Unix? Okay, these programs are running within this bubble, and this bubble is connected with input and output devices. Actually, one input device, the keyboard by default, and this input device is called the standard input, and it has an ID of 0. The output device is called, actually we have two output devices. One output device is called standard out, and the other output device is called standard error. Standard out has the ID 1 and standard error the ID 2. And how can we make use of that? If I want to redirect the output into a file, I can do it as follows. I can state the command, use the greater sign, and say the output of standard out, this channel 1, should be redirected into some file, let's say foo. And now you see no output on the terminal because this connection of standard output, which by default is connected with the terminal, was redirected into a file. And now this file foo contains what you previously saw on the terminal. So this is nice. If you want to send me some behavior of your program, that you want to tell me my program prints out the following, and I have a problem for this or that reason, you don't have to send me screenshots. You just redirect the output of your program into a file and send me this file per email. So that's helpful. But now assume that you want to send me some error message. Let's say you have problems with compiling something. For example, you want to compile the file hello_.c, and this file does not exist, and that's why this command, which also runs inside a bubble, just like a.out before, fails. It prints an error message. By the way, you also see that the exit code of this command of GCC is different from 0. Usually, all Unix processes follow the convention that the exit code of 0 means everything is fine, and different from 0, something went wrong. And GCC had this exit code of 1 because there was no such an input file. Okay, but back to my actual intention. Assume you want to send me this error message. Then you now could think, well, let's just redirect the output of this command into error. But then you see, still on the terminal, you see this error message, and the file error is empty. That's because error messages are not sent to this standard out with ID 1. They are sent to standard error, this second output device, which also is connected with the terminal by default. And if I want to redirect error messages into a file, I have to say redirect channel 2, the error messages, the standard error messages, into this file. And now this file error contains actually these error messages. And you also can observe that by playing around with this C file. I can use the function fprintf, which works similar to printf, except that I now have to specify to which channel, actually the right thing would be to which file descriptor things should be sent. And so here I would say this hello world message, actually I should change it, let's say, into some error, that this string actually should be printed on the device to which standard error is connected. So I can change this program a bit like that. Compile it again. Now first I will just execute it as before. Then it prints on standard out hello world and on standard error some error. But because both are connected with the terminal, you don't see a difference. But you see a difference if I now do the following. I redirect standard out to message, and with to $error, I'm redirecting all the error messages to the second file. Then you see in message I have hello world, and in error I have some error. Now assume I want to have the things that were sent to standard and the things that were sent to standard error in one file. So I want to have these two lines in exactly the order that I saw before on the terminal in one file. Then you probably come up first with the following idea. I redirect standard out to message and also standard error to message. And let's look at it. So this did not work. The right way to do that is as follows. You first say standard out should be disconnected from the terminal and connected with file message. And then you state the standard error important that you do it in this order, that you first direct standard out to this file message, and then you connect standard error, that's this ID 2, with whatever ID 1 that standard out is connected. And if you do it in this way, And you see that now message contains exactly what you saw before in the terminal. So this pattern basically is the right way to send me some output that contains first some regular messages and then in the end or in between some error messages, some mix of regular messages and errors. Okay, so that's it for this video, for this little Unix workout, and see you.